So let's just see the question number 2. Question number 2 says determine which of the following polynomial has x plus 1 a factor. So let's just start with the first part. Let us suppose we are taking the first part, p of x has nothing but x cube plus of x square plus of x plus of 1. So by the factor theorem, by using the factor theorem, what we can say that x plus 1 is a factor of this particular polynomial if p of minus of 1 should nothing but is equal to 0. So let us suppose we are finding out the zero of the linear polynomial x plus 1. It will be nothing but x plus 1 is equal to 0. So x is equal to minus of 1. Now let's just substitute this value into the polynomial. If it will satisfy this value, or it will give the answer as nothing but is equal to 0. So it means it is a factor, else it is not a factor. So let's just substitute the value minus 1 cube plus of minus 1 whole square plus of minus of 1 plus of 1. Now let's just solve it. It is minus of 1 plus of 1 minus of 1 plus of 1. So all the values are getting cancelled with each other. It means that p minus of 1 is equal to 0. Hence it implies that x plus 1 is a factor of p of x using the factor theorem. Now let's just talk about the second part. In the second part, again, let us suppose we are taking this particular polynomial as q of x, which is x cube minus of x square minus of 2 plus of root 2 of x plus of root 2. Obviously, x is equal to minus 1 is nothing but the value, and we have to substitute this value in q of x, and if it is equal to 0, then it is a factor, else it is not. So let's just substitute x is equal to minus of 1 in this particular polynomial. So it is q of minus 1, which is minus 1 whole cube minus of 1 whole square minus of 2 plus of root 2 of minus 1 plus of root 2. Now let's just solve this particular polynomial. First of all, we have minus 1 whole cube, which is again minus of 1, minus 1 whole square is plus of 1, so it is minus of 1. Let's just solve minus and minus is nothing but plus, so it is plus 2 plus root of 2 plus of root of 2. So the values are, if we are substituting x is equal to minus 1 in here, so minus and minus get plus, so it will be plus, so it will be 2 plus of root 2 plus of root 2. So let's just solve the values. We know that minus 1 is nothing but minus of 2 plus of 2 plus of root 2 plus of root 2. So minus 2 and plus 2 get cancelled. Root 2 plus root 2 is nothing but 2 root 2. So obviously this value is not is equal to 0. So if this value is not is equal to 0, it means that by the factor theorem we can say x plus of 1 is not a factor of q of x, because it is not giving the answer or the value as is equal to 0 as per the factor theorem. So let's just move on further toward the question number 3.